Hello everyone, my name is Timothy Lee Grant. So I actually already made a video, a LeetCode video today, but unfortunately in that video I kind of went a little bit dark after I was unable to solve the problem. Still unsure if I'll actually post that video. Yeah, anyways, to try to lift my spirits, I am going to just try to solve an easy problem today. Just go through depth first search, do an easy problem. Just, yeah. And I forgot to have myself float on top. So let's float on top. Yeah, here. This is one of the problems. So I was unable to solve this one, and anyways, so yeah, then this one was the one from yesterday that I did post this video, and I couldn't get this one as well. So stacking, like not being able to do it, and then not being able to do it, and just like feeling horrible about myself. But yeah, so today I am going to try to do just an easy problem. So let's come here. We're doing depth first search, and we're gonna do the closest easy that we see. Anyways, okay, go up until we get an easy. Closest binary. No, we're not doing this one. Okay, so we already did this one. Both of those were done. All of these are done. Symmetric tree. Okay, that's the next one. All right, well, let's... I was about to say, like, what if I can't solve this one? We're not going to think of that possibility. Anyways, 101 symmetric tree. Given the root of a binary tree, check whether it is a mirror image of itself, i.e. symmetric around the center. Okay? So here we have our root node, and then we have its left child and its right child are the same, and then their left child. Okay, so immediately what I'm seeing is that it's kind of, I have to take the opposite. So I go right here, I go left here, but then for this one I have to go left to find the opposite, or the one that I'm looking at. And then this one I have to go right to find the one that I'm looking at. So that I'm trying to think in my head, like, okay, how am I going to traverse this tree such that I can get its corresponding counterpart? Okay, and then the other thing that I'm noticing, have I done this one? Symmetric tree. Hold on a second. 101 symmetric tree. I thought it 101 symmetric tree. No wonder. I was like, wait, hold on. This one seems okay, so I think I know what's up. I did this problem. I attempted this problem, but I couldn't do it. That's why it didn't have that little green check mark. I see. Okay, I was confused. I was like, I'm pretty sure I saw this video, or I'm pretty sure I saw this problem before. No wonder. Okay, I was like, am I going crazy? What's going on? Okay, so I've seen this problem before. I couldn't solve it. But let's see if I can solve it today. Okay. This also puts the pressure on me. Like, I've seen this problem before, and I did a video on this problem. So I obviously did the attempted the problem, couldn't solve it, and then did the autopsy portion of the video. And so in the autopsy portion of the video, I tried to understand the problem and figure out what I did wrong and how to improve. If I'm unable to solve it here, then that means obviously I didn't do a very good job in the autopsy portion. Okay. Well, let's see. I guess I'm gonna do def traverse and node. Okay. Now what do I want to do? How am I my first question that I'm trying to figure out is how do I actually keep track of the corresponding node mirror image? So, and the other thing that I'm seeing, and I remember this is what triggered my I think I've seen this before, was this node here is not needing to be a mirror image. So what I mean is this node, when I look at it, its children do not need to have mirror qualities. This is a 3 and this is a 4. So I don't need to be able to put a mirror here and get symmetry. Which means, how do I use recursion to perform this? I'm trying to think how they did it in the last, when I was doing the video on this problem, this very same problem. How did they do it? The way that I'm thinking about how I might be able to solve this is to have essentially cut this graph in half. Bam. I cut it in half, and now I essentially have two graphs. Okay? Then what I do is, in my traverse function, I have logic for going left on the left graph and going right on the right graph, and then I just keep checking each time I go down the graph, I will go down on the left side, or on the left graph, and I will go right on the right graph. And so I will be doing the opposite direction. So, okay, I'm at the root node. Now, I have different logic for the left graph and different logic for the right graph. On the node, I will go right for the right graph, left for the left graph, and then check, like, are these the same thing? If no, then I say it's false. It is not symmetric. Then I, do my recursion on the right graph and on the left graph. Now it comes back up, and now I have two nodes again in this recursion traverse function, and then I do the corresponding opposite calls. Okay. So what would it be? Left node, right node, kind of like this maybe. If not left node and not right node, return true, because it's symmetric. Okay, if not left node, return false. If not right node, return false. Okay, so what I'm thinking about, the base cases are if both left and right don't exist, then that portion of the graph is symmetric. So like, for example, if I tried to traverse on this 3 node right here, I try to traverse left, and on this one, I'm going to try to traverse right. Okay. Well, it will be left node does not exist, and right node also does not exist. Or actually, let me kind of like change this a little bit more. Left tree node, right tree node. Copy and paste that. Copy, paste, paste, paste. Okay, make sure that all of this is good. Make sure all of this is good. Yep. Okay, so make sure if the node that I'm evaluating on the right hand side doesn't exist, and the node on the left hand side that I'm evaluating does not exist, then okay, that portion is symmetric. If, for example, let's say that this 3 didn't exist here on this side, but it did on this side. So right now I'm at this 2 and 2, and then I come down here, and now I'm looking at this 3, and then I'm coming down here, and this doesn't exist, so it's null. So if this exists and that one doesn't, if the left-hand side node does exist, but the right-hand side doesn't exist, then I can, bam, just return false because it's not symmetric. One side exists, the other side doesn't exist. So the shape isn't even correct. So that's why I said here, if it's not, if the left hand, or if the left tree does not exist, the left tree node doesn't exist, or the right tree node doesn't exist, then I return that it's false, because that's after checking if both don't exist. If both don't exist, then I'm okay. Then I'm cool. If this one doesn't exist or this one doesn't exist, then there's a problem, because it means that the other one does exist. Okay. So now, what do I want to do? I want to check if the corresponding nodes match up with each other. So I'm like on 2 here and 2 here. I want to see if their values are the same. So if right tree node dot val does not equal left tree node dot val, then we can return false. Okay. So now I want to actually traverse this tree. Yes. So I want to on the okay, so let's see. I'm here, and what do I want to do? I want to go right. So I'm here and here. The left tree node is this one, and the right tree node is this one. So I want to traverse. Okay, so left tree node dot right, left tree node dot right, and then on this one, this is right tree node, and I want the left child dot left. Okay. And now, so I come down and explore all of the options here in the lower levels. And then I want to come back up, and I want to then go to the opposite side. So I'm now here again and here. So I'm at this same level. So here and here. So now I want to go traverse again. Traverse, and I want, this is the left tree node dot left. I want to go left, and then on this one, this is the right tree node dot, and then I want to go right. So I'm going to check this one, and then check, wait, okay, left tree node dot left, left tree node dot left, and then right tree node dot right. So I'm going to check this one, and I'm going to check this one. So now I want to get the return value. I want to see, because this recursion is going to check if all of the nodes, if any of those nodes below it were not symmetric, it's going to, I want it to return false all the way up. So result 1 equals this one, and then result 2 is going to equal the, so result 1 is going to be like this one, the left tree dot right. So it's going to investigate all of the subtrees down here on along this path, and if any of those are found to be false, it's going to return false, 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 all the way up here, false. And then if this one gets a false from either this subtree or this subtree, I want to return false up to here. And now this one is going to do the same thing. It's going to check this subtree and this subtree. If either one of those are false, then it's going to return false. And that's how I can return, like, hey, yeah, this function or this tree is false. It's not symmetric, so there's a problem with it. Otherwise, it's going to come all the way down to the base case. Okay, this is going to be true, and then this one is going to be true. So now this 3 says, okay, I got true and true, so I'm going to pass up true to here. This one is going to come down, back down here. It's going to look, okay, true, true, and then it's going to pass up true to this node. Now this node is going to say, okay, cool, so I got true for both left and right subtrees. Then I'm going to pass it back up to this 1 as true, right? And then, so from the perspective of this 1, he's looking, okay, well, I got a true from here and I got a true from here. Must be, I am symmetric. Okay, so return R1 and R2. So if either one of these is false, it's going to return a false. Okay? If both of them are false, it's going to return a false. This statement is only going to be true if both R1 and R2 indeed are true. Okay, so now actually using the function, so if not root, return, is it guaranteed that there is a node? Okay, so there is a node in it. Number of nodes is 1. Okay, so I don't need this because it's guaranteed that there is a node. So I just need to return traverse, and then I need to pass into this traverse function this child and this child. So let me, okay, so root dot left and root dot right. Okay. I think this will work. Let me run this and then explain kind of more of what I did. Let's see. Does it work? Does it work? Please work. Okay. Okay. So I haven't submitted yet, but at least it passed the sanity check. Oh, okay. I'm actually pretty glad about that. Okay. I'm actually very happy about that. I'm just want to submit. I just want a confirmation. Please work. Thank goodness. Okay. Thank goodness. I wanted confirmation about that because I have been having a rough couple of goes at it. Getting pretty upset about, not upset, but like depressed at LeetCode, honestly. Anyways. So okay, there we go. So the reason that I passed in the left and right child is because this root node, it could be anything. It could be 5 and it still passes that symmetric test. It could be 2 million and it still passes that symmetric test. Let's say that this didn't exist, this entire subtree didn't exist, and this entire subtree didn't exist. And what's going to happen in that case? Well, this is going to be null, and this is also going to be null. So I pass null and null into here, and it automatically just triggers this if statement right there and returns true, which makes sense, right? Like you have a single node, it's a root node, and it's just like 10. This is 10 up here, and has no children. Yeah, that's symmetric. And so that's why I just passed in the left subtree, because I'm just looking at this subtree here, and I'm looking at this right subtree right here, and then each traversal iteration, I'm going to be looking, okay, well, I see this one, and I see this one, right? That's what I passed in here. This node and this node, I'm going to check if either one, if they both don't exist, then everything is okay because that satisfies the condition of symmetry, because both sides of that tree for that portion of the tree don't exist. So that portion of the tree is, in fact, symmetric. So then I pass that back up. If one of them exists, but the other one doesn't, okay, well, that does not satisfy symmetry. So I pass up false. So I would just pass false up, and this would return false, right? Likewise, if it's the opposite, here, it's the opposite. Okay, that's also false. Now, if either one of those values, if this 2 doesn't align with this 2, then I know we have a problem, that it's not symmetric, so it just pass up false, because it's not symmetric there. Then what I want to do is now I want to recurse down the tree, and I want to recurse following the rule, which is, okay, for this node, what is the corresponding mirror image on the right hand side? So if you look at this is the what? It is the left subtree, right? I'm looking at the left subtree, and I have a particular node of that left subtree denoted by this right here, this left tree node. And I also have the corresponding node of the right subtree. So now I want to check, okay, we'll do all of the nodes in this left subtree. Does the right path match this right subtree's left path? Does that make sense? So just looking at the graph, this subtree, it's the left subtree. Look at the right-hand path, and that associates with this right subtree's left-hand path, which is exactly what I did here. So left tree node dot right, left tree node. I'm looking at this left tree, and I'm looking at this specific node, and then I go right. Now, then I look at the right tree node, and I'm at this one. I look left. And then I do the same thing here. I say, okay, well now I check, does this node match? Does this node match? Right? Because now I have two that I'm inspecting at the same time. And then I say, okay, if they both are not existent, then it's symmetric. If one exists and the other one doesn't, then it's not symmetric. Likewise, if it's the other way around, not symmetric. And if the values don't match, it's not symmetric. Otherwise, continue to, if there were more down here, I would continue down that path and keep investigating. Does every node match up with its mirror image? Yes or no? Okay. And then I would keep popping back up, and now I would get some value, either a true or false, and that would be returned back up to me, to this node here, to like this check, which is checking both this node and this node at the same time. So it's checking two nodes at the same time, right? So this one would be returned true because it says that the path along here and here are symmetric. So now I need to check the path along here and here, which is what I'm doing in this call. I have my two nodes of the two subtrees, and I'm looking at the left subtree, and I am going left. Left subtree, left. Then I'm looking at the node on the right subtree, and I'm going right. And I'm seeing if these nodes are the same, and then likewise, because this is recursive, I'm going to be looking at all of the pathways down. And then I'm going to return. Once I get back from here, I'm going to say, okay, this value represents if this pathway and this pathway were symmetric, and this result means if this pathway and this pathway was symmetric. If either one was not symmetric, I just return a false. If both of them are symmetric, then I need to return back up a true, that yes, it is symmetric. So there we go. Got it. God, I'm gonna get back to that accepted because I need, there we go. I like that. Okay, thank goodness. Okay. Anyways, I am going to leave it there. I said that I was going to go and look at those. Not there. I was going to do an autopsy on those two problems that I couldn't solve. Both. One of them was today, the video that I didn't post. Hold on, let me come here. So I still need to do an autopsy on this one, the number 404, sum of leaves, and then wait, yeah, here we go. Sorry, 417. Pacific Atlantic water flow. So I need to do an autopsy on this one to discuss like what I did wrong and how I can fix it and make sure that I am able to move forward. And just like with what I did here, right? Like in this one, apparently I wasn't able to solve it because it didn't have that green check mark. But because I did the autopsy, I learned what happened, where I made my mistake, and how to do it. And when did I post it? It's the 14th. So it's 5 days ago. And to be honest, I kind of forgot how to do it. um, I when I was looking at it, I was like, the problem seems familiar, but the idea of how to solve it was completely gone out of my mind. I have no idea. But anyways, so that's kind of the point, that I was not able to solve this one or this one, both of these, the 7 to 1 accounts merge. So I need to do an autopsy on both of them. I need to figure out like what went wrong, what skills I need to learn to make sure that I'm able to have the skill set required to solve these problems, and then get to the point where if I see this problem again after maybe 5 days, 10 days, I will be able to kind of work through it. So I need to create both of those autopsy videos. That's going to be coming up in the future. So look out for those. Anyways, thank you guys for watching this video. Subscribe if you would like. My name is Timothy Lee Grant, and I will see you tomorrow. All right. Feels nice to actually have succeeded. I was worried when I saw that it was already one of those videos that, or one of the problems which I have done, because I was like, number one, this isn't easy. So if I can't solve it, it's going to be a huge, like, stab to my heart. And I'm already feeling really low because of these two. In particular, like, yeah, this one, it was one that I have seen already, and I was unable to solve it the second time, and so that's why I was like, oh, man, what is going on? And then if the same thing happened to me on this one, which was an easy, and I was unable to solve it, I would have been like, oh no. So I'm glad I was able to solve it. I'm really happy about that. Um, yeah, so I will see you guys later. Have a wonderful day, and goodbye.